Hello everyone, I am Solanki Bhumit, currently pursuing my BTech degree from IIIT ICD. Today I am going to present you my presentation on nuclear power plant under the guidance of Dr. Jignesh Patel. First we are going to look the content of presentation, introduction, basics functionality of power plant, types of nuclear power plant, how nuclear power plant operates, details about nuclear fission, details about nuclear power plant, benefit of nuclear power plant, drawbacks of power plant, conclusion and references. Now quickly move to introduction. In recent time, nuclear power plant have become a major contributor of world's energy production. Nuclear energy made up around 10% of global electricity generation in 2020 and create more electricity than all the wind and solar PV generation put together. Also, nuclear power is a clean energy resource. Now, question arises, what is a power generating plant actually? Power plant is facility designed to produce electricity on a large scale. There are many different types of power plant, but they all work on the same basic principle. They use a source of energy to create a mechanical power which is then used to turn a generator and produce electricity. Power generating plants are crucial for providing electricity to homes, business, industries, and infrastructure. They play a vital role in powering modern society and supporting economical activities. Types of nuclear power plant. There is mainly two types: pressurized water reactor which is known as PWR and boiling water reactor which is known as BWR. First one is pressurized water reactor. Water in this water under high pressure is used as both the coolant and the moderator. The primary coolant circulate through the reactor core where nuclear fission reaction occurs. Observing heat in the process, the heated water passes through a heat exchanger where it transfers its heat to a secondary water loop without mixing it. This secondary loop produces steam that drives a turbine connected to a generator, producing electricity. PWR, the most common type of nuclear reactor worldwide, known for their reliability and safety features. Now, second one is BWR. In BWR, water is allowed to boil directly in a reactor core, producing a steam that drives a turbine connected to generator. Unlike PWR, where water remains pressurized in BWR, the water is in the reactor vessel boils directly due to the heat generated by the nuclear fission reaction. The steam produced by the boiling water in directly used to drive turbines, eliminating the need of separate heat exchanger. BWR similar in design compared to PWR, but they have some unique safety consideration due to the direct use of steam from the reactor. Now, question arises, how actually nuclear power plant operate? Basically, a nuclear power plant is a facility that uses nuclear fission to generate electricity. A nuclear fission is the process of splitting an atom's nucleus, releasing a high amount of energy. This energy is used to heat water, which creates steam. The steam spins a turbine which turns a generator and produces electricity. In nuclear power plant, controlled nuclear fission reactions are used to generate heat, which, which is then convert it into electricity. What is nuclear fission? Nuclear fission is a process where the nucleus of an atom, typically a heavy nucleus like uranium-235 or plutonium-239, is split into two or more similar nuclei, along with release of energy and additional neutron. There is three-step. First one is initiation. A neutron collides with the nucleus of a uranium-230 235 atom. Second, fission. The impact from the neutron makes the uranium-235 nucleus become unstable. This unstable nucleus split into two lighter element nuclei, releasing a large amount of heat and radiation. Third one, chain reaction. Importantly, during the fission process, several additional neutrons are also released. These newly released neutrons can then go to the collide with other uranium-235 nuclei, causing them to fission as well. This creates a chain reaction where one fission event triggered multiple more fissions, releasing a significant amount of energy continuously. How it works. A nuclear power plant functions by harnessing the energy from nuclear reactor to generate a significant amount of heat. This heat is then employed to produce steam either directly or via a steam generator. The steam in turn propels a turbine linked to a generator, thereby producing electricity. In essence, the core principle of a nuclear power plant lies in utilizing nuclear reactor to generate heat, which is then converted into electrical energy through the steam turbine process. Typically, this power plant features reactor with a normal thermal power output of approximately 3400 megawatt. Details about nuclear power plant. There is some basic term. First one is nuclear fuel. The heart of nuclear power plant is its reactor core, which contain nuclear fuel. The most common fuel used in a nuclear reactor is uranium-235, although some reactors use plutonium or thorium. Uranium fuel is typically in the form of ceramic pellets stacked inside metal fuel rods. Second one, fission. Inside the reactor core, the uranium atom undergo a process called nuclear fission. Third one, heat generation. The heat produced by nuclear fission is used to heat water in a closed loop system. This water is kept under high pressure to prevent it from boiling. The heat is transferred from the reactor core to the water through a heat exchanger, heat steam generation. The hot water from the reactor core is used to produce steam in a separate loop. This steam then drives a turbine connected to generator similar to those used in other types of power plant. As the turbines spin, they generate electricity. Cooling. After passing through the turbines, the steam is cooled and condensed back into water. Using separate cooling system, the condensed water is then returned to the heat exchanger to be reheated by the reactor core, and the cycle repeats. Safety system. Nuclear power plant have a multiple safety system in place to ensure safe operation and prevent accident. These systems include control rod, which can be inserted into the reactor core to observe neutron and slow down or stop the chain reaction, as well as various backup cooling systems to prevent overheating in the event of a loss of coolant or other malfunctioning. Container building. These thick-walled structures surrounded the reactor core and act as the primary barrier in case of accident. It helps contain radioactive material within a building. Reactor vessel. This thick-walled steel vessel houses the reactor core. It contains the fuel assembling, controller, coolant, and moderator. Reactor core. This is the heart of the nucleus reactor where nuclear fission takes place. It houses the fuel assemblies which contain fissile material like uranium-235. Steam generator generators. These large heat exchange transfer heat from the reactor coolant loop to a secondary water loop, creating steam to spin the turbines. The steam spin the turbines blades, converting thermal energy from the steam into mechanical energy. Generator. The rotating turbine shaft is connected to the generator, which convert mechanical energy from the turbine into electrical energy. Transformer. The transformer increases the voltage of electrical generated to facilitate transmission over long distance. Cooling tower. The structure is used to reject the waste heat from the steam back into the environment. Cooling tower use either air or water to cool down the water used in the condenser. Condenser. This heat exchange condenses the exhaust heat steam from the turbines back into water, which can then be pumped back to steam generator to repeat the cycle. Cool water source. This can be a lake, river, or ocean that provides a cool water source for the condensation to cool down the circulated water. Pumps. Water pumps are used to circulate water throughout the system. There are pumps for a reactor coolant loop as well as for a secondary loop to generate steam for turbines. Overall, a nuclear power plant harnesses the energy released by nuclear fission to generate a large amount of electricity with relatively low carbon emission. However, they also pose unique challenges including the safe handling and disposal of radioactive waste and the risk of accidents as such as meltdown and or radiation leaks. Now we see benefits. First one, carbon-free electricity. While traditional fossil fuel generators source pump massive amount of carbon dioxide into the atmosphere, nuclear power energy plants do not produce carbon dioxide or any air pollution during operation. Second, small land footprint. Nuclear energy plants take up far less physical space than other power plants. Third one is high power output. Nuclear power plants produce high energy levels compared to other power sources, making them a great provider of baseload electricity. Fourth one is reliable energy source. Lastly, nuclear energy is a reliable renewable energy source based on its constant production and accessibility. Now we see drawbacks. First one, uranium is a non-renewable. Although nuclear energy is a clean source of power, it is technically not renewable. Current nuclear technology relies on uranium or of fuel which exists in a limited amount in the earth crust. Second, high upfront cost. Operating a nuclear energy plant is a relatively low cost endeavor, but building in its first place is very expensive. Nuclear reactors are complex devices that require many levels of safety building and around them, which drives up to cost nuclear power plants. Third, nuclear waste. And now to the theorem issue of nuclear waste. Nuclear waste is a complicated issue and we won't claim to be anything near expert. Nuclear waste is radioactive, making it an environment and health catastrophe waiting to happen. Malfunctioning can be catastrophic. A nuclear meltdown occurs when a heat created by nuclear reactor exceeds the amount of heat being transferred out a cooling system. This causes the system to exceed its melting point. If this happens, hot radioactive vapor can be escaped, which can cause nuclear plant to melt down fully and combust, releasing harmful radioactive material into environment. The last thing, Chernobyl disaster, which is happens due to nuclear power plant. The primary issue of the Chernobyl disaster was a flawed safety test conducted at the Chernobyl nuclear power plant in Ukraine on April 26, 1986. The test, coupled with design flaw and operator errors, triggered a catastrophic reactor explosion and the release of radioactive material into the atmosphere. This led immediate death, long-term health consequences, mass evacuation, and widespread environmental contamination. These are the references which is used in this presentation. Thank you.